Welcome back everyone. We're going to continue with 4.3, this time Theory C, which is all about factorizing. Let's take a look at what they mean with that in this case. First, I've written down two different calculations here. The first one we can calculate. We now know that the square root of 50 squared, the square and the square root cancel each other out, so I get 50. This one we can also calculate, right? If I have a square of 5 root 2, I have to square the 5. I have to square the root 2. That gives me 5 squared times root 2 squared gives me 25 times 2 equals 50. Seeing those two different calculations, what can we now conclude from them? Well, if you watch closely, you see that they both give a result of 50. So that means that the two calculations must also be equal to each other. Apparently, root 50 squared is the same as 5 root 2 squared. Balance method says if I now take the root of both sides, that must give me that root 50 apparently is exactly the same as 5 root 2. And I'm going to show you in depth how to do that, because we want to do that. This is what we call factorizing. You can read this one for yourself. It's in your book. I'm going to show it with the example here to the left. Let's say we have 50 and we can say that 50 is equal to 25 times 2. We can also say that root 50 is equal to root 25 times 2. And we can also split those two square roots. And it might seem strange to do, but we already know that rule. Because if we had two separate roots, we could have combined them into one root. Well, we can also do that the other way around. If I have the root of a multiplication, I can separate them into separate roots again. Why, would you ask maybe? Well, because this time I can calculate the root of 25. I could not calculate the root of 50, but I can calculate part of the root, in this case the root 25 part. That's 5, and 5 times root 2 we can write down as 5 root 2. And this is what we call factorizing, or in Dutch een factor voor het wortelteken brengen. And we want to do this. We want to always, when we simplify square roots, factorize in such a way that I get as much as possible out of the square roots. And you do that by looking for nice squares. I'm going to show you in a moment what I mean with that. Some numbers you cannot factorize. For example, square root 30, I cannot factorize because I can write down 2 times 15, and then I can write down root 30 is root 2 times root 15, but I cannot calculate those. I can write it down as 3 times 10, but those I can also not calculate mentally. And 5 times 6 I can also not. So root 30 you can leave as it is. But for example, root 24 I can write as root 4 times root 6. Why would I do that? Because I can calculate root 4 mentally. And then I get to square root 4. So you have to use that list, root 1, root 4, root 9, root 16, 25, 36, 49, etc. You have to use that again. And in the correct way, because, for example, root 32, I can factorize in 2 different ways, and we don't like that. I would like to only factorize in one correct way. Let's take a look. We can factorize 32 by writing it as 4 times 8. I can do that because I can calculate the separate root of 4, which is 2. So apparently 2 root 8. But if you look a bit more closely, I can also rewrite it as 16 times 2. That is, square root 16 times root 2 is 4 root 2. Now those are 2 different ways to factorize. And I want to show you there's only one correct way. Which one? The last one. Why? Well, that's an agreement. When simplifying, we want to take the largest factor possible outside of the square roots. Here 4 is bigger than 2. So this is the way that I want to factorize. You can also say I want to be left with as low a number that I can inside of my square roots. Why is this one not correct? Well, because if I take a look at this more in depth, 8 can also be factorized again into 4 times 2. So I'm not done here, you can say. Here I am done. I cannot factorize root 2. Factorizing can help you with simplifying, because previously you would say root 54 and root 24 I cannot factorize. Why not? Because they're not like roots. Well, I have good news for you. You can now actually add them up. You have to factorize them first though. So here, which two numbers times each other are 54 in such a way that I can also calculate one of those roots? So in that case, I have to take a look at the roots, right? So here I could take a look at 2 squared equals 4, but I cannot do 4 times something is 54. If I take a look at the next one, 3 squared is 9. Hey, I can write this as 9 times something, right? But let's check just to be sure, because I have more squares that I can use. And I always want to try and find the biggest one. Well, here I'm done already, because 54 cannot be written as 16 times something and also not as 25 times something. The next one, 36, is too big. I know that cannot fit nicely. So I have to rewrite this as 9 times something. For 24, take a look at the same list. Which number can I use? Hey, I can write 24 as 4 times something. 4 times what? 4 times 6. So my next slide, I have written this as square root. I'm going back to my pointer right now. This as 9 times 6. So the square root of 9 times the square root of 6. And this as 4 times 6. Why do I do this? I can now calculate root 9 and I can calculate root 4, which gives me 3 root 6 plus 2 root 6. And this I like because these are like roots again. So my final answer is 5 root 6. So when doing exercises like this, it's of major importance to know the squares, right, and the square roots. So the first number that you use, here root 4 and here root 9, is always one of those. Root 4, root 9, root 16, root 25, root 36, root 49, root 64, root 81, root 100, etc. Root 121. Why? Those, if I find them separately like this, I can calculate as 2, 3, 4, 5, 6, 7, 8, 9, 10, etc. And that's what I want to do. So the first square root is always one of this list. I purposely did not write down square root 1 because square root 1 doesn't help you here, right? If I write down square root 54 equals square root 1 times square root 54, yeah, that's 1 times square root 54. I wish you good luck. I did not do anything here. Okay, so don't use square root 1. Practice this. This does seem a bit puzzling at first, but if you practice enough and ask enough questions during the lesson, of course, I'm sure you can do this as well. Good luck, and I will see you in lesson.